section is called 6-7, converting to standard form. So what we're going to do is take a look at the two different forms of a quadratic we've really been studying, vertex form and factored form, and we're going to learn how we can change that to standard form of a quadratic. So on Google Classroom, also in the chat, I'll put this link for the Desmos. First one's a warm-up. How are you feeling this, today on the Shaggy scale? And then another warm-up, show how you can multiply 52 times 79 two different ways. Do you know two different ways to multiply those together? And in class we'll discuss different methods that you've come up with to multiply those two numbers. And then we'll start together with this one. Use the area model to find the product of 64 times 38, which we can break down into 60 plus 4 times 30 plus 8. So some of you may have used this model to multiply our first two numbers together. Let's take a look how we can use the area model to multiply 64 and 38. So we're going to write or draw a rectangle. Why a rectangle? Well, it's easy to find the area of a rectangle, base times height. And again, we can convert this 64 right here into a 60 plus 4, and we can convert this 38 into a 30 plus the 8. And now let's find the area of each of these boxes. So for the first box, we have 60 times 30. We can get that product by multiplying 3 times 6, which is 18. And then there's the two zeros, one from the 60, one from the 30. In our second box, let's do 4 times 30. So that'll give us 120. In this bottom box right here, we can do 8 times 60. So 8 times 6 is 48, and then there's the 0 from the 60. And then in our last box, we can do 4 times 8, which is 32. And the area of if we add up all these four boxes, that will be the total area, which will give us the product of 64 times 38. So let's add these together. I'll just stack them. It's easier for me to stack them. So 1800, we got our 120. We got our 480, and we have our 32. We'll add them together. So I'll get 2, and then we have 8, 9, 10, 11, 12, 13, 8, 9, 10, 14. All right, so I'm getting the product of 64 and 38 to be 2,432. Ooh, we should double check our answer. 64 times 38. Using the area model, did we get it? And we did. So that's one way that we can find the area. We can break it up into different parts and find the area of each rectangle being base times height. So we're going to take that and apply it to the product of something in factored form. We have x plus 2 times x minus 1. Let's multiply that out together. All right, so in this first box, we have our x. Ooh, I can change colors here. I'll leave it blue. X times x, and x times x is x squared. In our second box, now I can change colors, the width, or length I guess I could say, is 2, and the height is x. 2 times x is 2x. In the lower rectangle, we have a width of x and a height of -1, so that would be -1x. And then in our last box, we have 2 times -1, which is -2. So in our first example, we multiply each box, and then we combine like terms. So I'm going to do that. I have just the x squared there, and I can't combine it with anything else, so I'll just leave it x squared. Oh, that's terrible. All right, so x squared. And when I look at the x's, I have the 2x, but also a -1x. So this is the same as 2x minus 1x, which would leave us with 1x. So 2 minus 1 is 1. So I could put plus 1x or just x. And then we have our minus 2 in green, and we can't combine those with the x squared of the x's, so I'll just leave that minus 2. And what we've done is we've converted something from factored form, where I could tell what the x-intercepts are, to standard form right here, which does give us the y-intercept at -2. All right, so let's take a look. Recall the three different forms. Standard we haven't done a lot with, but this is where we're going to start doing a lot with standard form. And standard form is when you multiply it out. So we don't have any parentheses. We have ax squared, so a number times x squared, plus a number b times x plus some number c. Vertex form we have looked at, and we know that the a value makes it a frowny face or a smiley face. It can make the graph skinnier or fatter. If it's just 1, it's like the parent function. We know that h shifts our graph left and right, and it's the opposite of what you think. So plus h is to the left and minus h is to the right. K is up and down. And factored form, we know that if we have it with these parentheses here, we can look at what makes each parenthesis 0, which is typically was the opposite of in the parentheses, and that would give us our x-intercepts. And the x-intercepts are also called zeros or solutions. So here are the 3 different forms, and our goal today is to change from vertex form and factored form to standard form. So we're going to take the 2 that we're comfortable with, and we're going to multiply them out and change it to standard form. And then we'll go over what do we use standard form once we can do that. Okay, so this is in standard form, this equation right here, x squared minus 2x minus 3. I can tell it's in standard form. There's no parentheses there. And it says graph y equals x minus 1 squared minus 4. That's vertex form. And we have factored form right here. Okay, so vertex form is y equals x minus 1 squared, shift 6 gives us the squared, or use the keyboard, and then minus 4. Okay, so notice the blue then overlaps the red because it's the same. And then factor form, you probably can guess what's going to happen. So we have x plus 1, x minus 3. And again, it overlaps because this factored form is equivalent to the vertex form, and those are both equivalent to standard form. So again, we know different parts of the equation looking at the, or different parts of the graph looking at the equation, the vertex or the zeros. Standard form is going to tell us the y-intercept. If you look at that minus 3 right there, there it is on our graph. All right, our 3 forms, all 3 forms, should graph on top of each other because they are equivalent. Here's how to write each equation. 1 is standard form. 2, we can find the vertex, 1, negative 4. And 3, we can find the zeros, negative 1 and positive 3. All right, so let's see if we can take the standard form and write the vertex in factored. So for vertex form, let's find the vertex. All right, so if we look at right here, it looks like it is 1, negative 25. So let's write that down. Y equals parentheses, and it was 1 to the right. So x minus 1, ooh, that's 2, and then squared. And then I said minus 25 to shift it down. Oh, and that matches, so we can tell we did it right. Factored form, I'm going to look at the zeros and do the opposite. So the opposite of negative 4 is 4. And the opposite of 6 is negative 6. And we can see that that graphs it as well. Okay, so again, we're given standard form. You should be able to type in vertex form with what we know about how the graph shifts, and factored form with what we know about the x-intercepts or the zeros or the roots of the graph. Let's do it again. Be aware that the a value has changed. Okay, so vertex form, this is skinnier. It's still a smiley face graph. And it looks like the vertex is at 0, negative 16. So first I'm going to use what I know about the vertex. So it's going to be x squared because it doesn't shift left or right, but it does go down. And I can probably guess, looking at standard form, what the a value is going to be. It's going to be bigger than 1 because it's skinnier. I'll guess 4 because I see the 4 right there. And then we can see that here vertex form is actually the same as standard form because it doesn't shift left or right, so it's the same. So I don't need those parentheses. All right, factored form. Let's look at the zeros and do the opposite. So y equals, the opposite of negative 2 is 2. And I have the zeros, but I need to make the graph skinnier, and it needs to shift down. Okay, so what happens if I just put the 4 there? Oh, and that takes care of both things, right? So it did make it skinnier, and it did give us the right vertex. If given factored form, you can convert it to standard form using the area method below or by multiplying. Show your work. All right, I am not great at writing on this, so I'm actually I'll pop it up on my iPad so it looks a little bit nicer. Okay, so I'm going to write it first. Y equals x plus 1 times x minus 3. All right, so goal number 1, can we change them from factored form to standard form, which means multiply it out. So first thing, I'm going to make our rectangle, and I'm going to put one of the factors on the top. It doesn't matter which one, so I'll put x plus 1, and I'll put the other factor on the side, x minus 3. And then we're going to find the area of each box. So the first box, I already used blue, is going to be x times x, and that's x squared. My second box will be 1 times x, which is 1x. My third box is x times, and this is a negative 3, so negative 3x, so the negative goes with a 3 behind it. And then my last box is 1 times, again, -3, which is -3. And then I'm going to combine like terms. I only see the x squared there, so I can't add it to anything else. But if you notice, I have a -3x and an x. I can put those together because they're both x's. So if we do that, we'll get -2x. And then we have our last number right here, -3. Again, you can't combine it with the x squared to the x. So now we've multiplied it out. What you've just witnessed is changing it from factored form to standard form. So again, we had parentheses, we multiplied it out, and then standard form, there are no parentheses, you've multiplied it out. So there's the answer to slide number 10. Multiply it out, show your work, and I did that right here. So we'll get x squared minus 2x minus 3, that's standard form. Okay, so now let's write them in all three forms. I'll write what I had for standard. X squared minus 2x minus 3. Y equals x squared minus 2x minus 3. Okay, so there's standard form. Vertex form. So we're looking at the red graph. I have to find the vertex. It looks like 1, -4. So y equals x minus 1, because it's the opposite of what we think. Ooh, to the 4th power. And then I have to shift it down 4, so -4. And then I do have to change my factored form right here. So it looks like my zeros are at -1. So I'll do the opposite of -1 is +1. Oh, okay, so this one is not relating to the previous problem. This is its own separate problem. I apologize. This one they wanted us, okay, so this one's a new graph. They wanted us to change from factored form to vertex and standard. So we do have to multiply this out. All right, so let's do that. Again, not great at writing at that. I'm going to go ahead and write this one on my iPad. So x minus 3, x plus 3. Let's write it out. So y equals x minus 3, x plus 3. We'll make our rectangle. We'll put one of the factors on top, x minus 3. We'll put one on the side, doesn't matter. One on top, one side, doesn't matter. All right, let's get the area for this. So my first box is x times x, which is x squared. My second box is -3 times x, which is -3x. My lower left-hand box is x times 3, which is 3x. And my final box is -3 times 3, which is -9. Let's combine like terms. We have our x squared. When we combine our 3x and -3x, that's just 0. That cancels. So then we just have our -9. So there's our equation in standard form. Notice you don't always need the x here. It did cancel out. So we have x squared minus 9, and that's standard form. So let's type that in here. Y equals x squared minus 9. And it matches. I think it matches because the green is on top. All right, we're going to assume it matches. All right, vertex form. Again, we need to know the vertex. Can I move this graph? No, but can I make this bigger? Yes, I can. All right, so the vertex, it doesn't shift left or right, but it does go down 9. So we would say y equals x squared, and then again -9 would shift it down 9. I'm assuming it's going to match because I just see the green. All right, so there it is. We got factored form. It ended up being that standard and vertex were the same because we didn't shift the graph left or right for vertex. Okay, another one. So again, we're going to multiply it out. We're going to write the standard form and see if we can get vertex form. So again, I'll do this on my iPad because I don't write very well in Desmos. Okay, so this one I have x minus 1, x plus 9. Okay, so first box, x times x, x squared. Next box, -1 times x is -1x, or just -x. Next box, x times 9 is 9x. And last box, I guess I'll just use green, -1 times 9 is -9. Next step, combine like terms. We got our x squared here. We have our 9x minus 1x, which is 8x. And then we have this -9 at the end. So there's our equation, and we'll type it in. Okay, that's standard form because we multiplied it out. So y equals x squared plus 8x minus 9. And it matches the other graph. Let's do the vertex. Oh, this one does shift. Y equals, and it goes left. Ooh, we're going to have to play around with this, it looks like. I'm going to guess 4, so x plus 4, and I'll square that. And then down 25. Oh, that was a pretty good guess. All right, I wonder if I can Can you change that? No, I can't. Okay. Next problem. All right, what about this one? So this one, in factored form, it gives us the factors, but it also has the -2. So this is like multiplying three numbers together. And when you multiply three numbers together, what you're going to do is you're going to multiply any two numbers together first and then multiply by the third. So I'll do an example of multiplying three numbers together. What if we had y equals 1 times 2 times 3? Again, to get the answer, you multiply any two numbers first. So 1 times 2 is 2. And then multiply it by 3. When you do that, we get 6. And it should work no matter what order we do it in. So I could have done 2 times 3 first, which is 6. And then 6 times 1, which is also 6. So when you're multiplying any three things together, you multiply any two together first and then multiply by the third thing. So when I'm doing these, I actually like to multiply my factors together first, and then I like to multiply everything by -2. You don't have to do it that way. You could multiply -2 by one of the factors, and then take that and then multiply it by the full thing. So maybe I'll show you, like, no, that one doesn't have an example. Okay. All right, so I'm going to show you the way that I would probably do it, but it's not the only way, so just keep that in mind. All right, so first I'm going to multiply x minus 3 and x plus 1. So x minus 3, x plus 1. Okay, so when I do that, I'll get x squared minus 3x, x, and -3. I'll combine like terms. X minus 3x is -2x. All right, so there it is, multiplying it out. But remember, we have that -2 in front. So my last step is I'm going to multiply each of these by -2, and I'll get -2x squared minus, plus 4x, because a -2 times a -2x is a 4x. And then a -2 times a -3 is 6. So here is multiplying out first the factors and then everything by -2. Here's what I get. Remember, a negative times a negative will be a positive. And let's type this in. So y equals, the negative will make it upside down, 2x squared. Oops, I forgot my negative. And then it was plus 4x plus 6. And then we can see it matches up. Let's do the vertex. We know it's going to be negative. We can see the a value. It's going to be -2, so I don't have to guess on that. So -2. And then how does it shift? It looks like it goes right 1, up 8. So right 1 would be -1, and then up 8. And then we can see it matches. Okay. So again, it's just multiplying it out. So this one I'll have you guys try. Multiply it out, x minus 2 times x minus 2. And then you can explain why the vertex form and the factored form are equivalent to each other. And the reason is there's a squared there, so it does mean write it twice. And then let's take a look at vertex form. I think this is the last thing that we want to go over, is just how do you convert it to vertex form. And then that's it. Okay, so let's take a look. All right, so last type of problem. What if I give you vertex form? How do you multiply it out? Okay, and this one they did for you. So when you're multiplying something out, you use order of operations. In order of operations, exponents come first. So when you have x minus 1 squared, what that means is x minus 1 times x minus 1. They do the box, just like we've been doing. They combine like terms. But at the end, you have this -4 hanging out. So we'll put that right here. And then the last step is the combine like terms. So first step, multiply x minus 1 times x minus 1. Step 2 was, here they combine like terms, CLT, combine like terms. And step 3, subtract that 4 at the end. And you can only subtract it really from this, the +1, so you get the -3. All right, so let's do one example, maybe two, of converting it to vertex form, and then I'll have you guys switch it from standard to factored as well. Or we'll do standard, but you'll get factored. All right, so let's do this one. X plus 4 squared minus 1. Oopsies. Okay, so this is y equals x plus 4 squared minus 1. Was that right? We better double check. Okay, so first step is we are going to multiply out x plus 4 squared. So to do that, remember, this means x plus 4 times itself. Because it's squared, it means multiply it by itself twice. We'll get the box. My first box is x times x, x squared. My second box is 4 times x, which is 4x. my bottom left-hand corner is x times 2, which is 2x, and my last box is 4 times 2, which is 8. Okay, so there's step 1, multiply x plus 4 times x plus 4. Second step, combine like terms. We have our x squared plus our 6x plus our 8. And then third step, I'll just do it in red. There was this minus 1 on the outside, so we are going to stick that right here and subtract the 1 and combine like terms. So we'll get x squared plus 6x plus 7. And there's the standard form, which you can type it into the Desmos and then see if you can figure out factored form. So I'll let you guys finish slide 16, and we'll do one more together, and then the rest I'll have you finish is like 2 more problems for your assignment. Okay, so let's take a look at, well, what if there's a number in front for slide number 8, problem 8, slide 17. All right, so this vertex form, we have that 2 in front. We have the parentheses, the squared minus 8. First step is the box. Okay, so I'm going to write this up. So I have y equals 2x plus 1 squared minus 8. Okay, here's what it looks like. First step, I'll do, I don't know, blue. We got to multiply out x plus 1 times x plus 1. We're going to use a box. X plus 1, x plus 1. In our box, the upper left-hand corner is x times x, which is x squared. 1 times x is 1x. X times 1 is 1x. 1 times 1 is 1. So you can get the area of each. Second step, let us combine like terms. So we have x squared plus 2x plus 1. And then we have this 2 on the outside. And really here you have the 2 and you also have the minus 8. But in order of operations, you multiply before you subtract. So after we combine like terms, we're going to multiply everything by 2 and distribute. So this is step 3. We'll get 2x squared plus 4x plus 2. And then our third step, we have this minus 8 at the end. So I'll stick the minus 8 right there, and we'll combine like terms. So we'll get 2x squared plus 4x minus 6. That looks like an equation that we had earlier. Let's type that in. So y equals 2x squared plus 4x minus 6. You can see it matches up. Factored form, we know the a value, it's 2. We can see that in the vertex form. We look at the zeros, it looks like -3 and +1. So the opposite of -3 is +3. The opposite of 1, or -1, or 1, is -1, so x minus 1. Ooh. And then we can see it matches. All right, so we've done 2 examples of vertex form. One had the number, the a value, and one didn't, so you can refer back to any of those to help you out with the last 2 slides, 18 and 19, and then the last one is just, do you have questions? And that's it, so finish that for your assignment.